Good afternoon, everyone. Thank you for the kind introduction, and I'm really happy to be here today. Many thanks to TechBlick organizers. So as an introduction, I can tell you that 5 years ago, before my story at XTPL, I was working on optoelectronic devices, and my goal was to transfer two-dimensional of the semiconductor structure to 3D. And actually, I knew how many challenges are with this transfer, having access only to traditional manufacturing equipments for this kind of applications. So today, I would like to show you how to use additive approach to print structures in a single micrometer scale. So I will start with this picture. I hope that all of you know wire bonding. In my opinion, this technology will stay with us for a long, long time. It's very fast and efficient way to make this kind of interconnections. However, we see, especially in beyond more applications, that there are challenges to actually find the alternative for some specific applications of wire bonding and how to connect two different layers, three-dimensional layers with high-density interconnections. So naturally, printed electronics, additive methods are one of the biggest candidates. And we see in the papers different approaches. I've just mentioned about two of them, inkjet printing and aerosol jet printing. Both techniques are great for some of the application. However, like most of the printing methods, they are jetting material from the top, which means that if you have a chip, which typically have a vertical sidewall, you cannot deposit directly on the sidewall. You need to add, for example, a ramp, which introduces another step in the fabrication. And also, typically, these methods are using materials which are lower viscosity. So if you add this low viscosity, water-like materials to the three-dimensional structure, you can imagine that in the areas like, for example, top edge of the chip, you can have some conductivity drop. Another two methods, printing methods I'd like to mention is electrohydrodynamic printing. Very nice method which gives you capability to go down to feature sizes below 10 micrometers. However, it requires high electric field and also materials with very low viscosity. And actually, speaking about the materials, there are a lot of limitations regarding to materials and the limitations to the substrates on which you can print. On the other hand, we have a very nice direct ink writing approaches, which can use materials with very high density, of metal particles, high viscosity, so you can print on any kind of substrates without any limitation. However, the resolution is not so good as with the EHD approach. So what we developed at XTPL, we actually combined advantages of these two methods. So high-resolution printing and use of high-dense paste-like materials. We call this technology Ultraprecise Deposition, UPD. And what is this technology, actually? So this is a micro-dispensing-like approach. It uses nozzles, which we are fabricating with very high precision, and the openings are down to 1 micrometer. The material is deposited using only pressure, so no electric field is required. We developed, together with a printing technology, material which has a very high stability over the time, so you don't have to worry about clogging issues or changing the geometrical parameters of the printed lines. And also, our printing head is moving